Hello friends, this is Showman from Oil and Gas Field Quality Control. Now let us go for the stress analysis. Pipe stress analysis provides the necessary technique for engineers to design piping system without outstressing or overloading the piping components and connected equipments. The objective of stress analysis can be listed as to limit the stresses in the piping system to the limiting value, to limit the deflection in the piping system to the limiting value, to limit the loads on the nozzles of connected equipments, to limit the loads on supports, to check the leakage at flange joints, unintentional disengagement of piping from supports, and excessive displacement. So all of this a design engineer considers before they are issuing you a IFC drawing or issued for construction drawing. So there are many stages of research and calculations so that they can develop a safe piping system which can last longer without any accident. Steps in stress analysis. It is very complicated, but still this is a simple flow chart for you to understand better. First, identify the stress critical lines or stress critical lines list. Then review stress isometric drawing. If it is acceptable, then freeze supporting arrangement, approve the stress isometric and communicate with civil, vessel and mechanical groups of loading. If it is not acceptable, then revise the piping study and isometric and then again review stress in the isometric drawing. So this is the way a stress analysis engineer is working. Familiarization of stress symbols. You can see some symbols over here: rest, axial stop and directional stop, anchorage, and there are guides, how it is mentioned in the drawing, spring hangers, what is the symbolic expansion, global coordinating system, X, Y and Z axis. This is for your basic information. There are many symbols used in a drawing which you will come to know when you will be encountering with the drawings day by day. Loads on piping. What are the types of loads coming on the piping? Static and dynamic, these are two types of load. Static loads can be divided in few categories like pressure, static load due to pressure, internal and external it can be, temperature, it can be restraint and differential growth, and static load due to the weight. It can be dead load, pipe and instant and inside material, then it can be live load, operating load, and maybe there is snow. In a cold country, there might be snow over the piping system, so that load also need to be considered in cold countries. And there can be a static load due to the friction. Okay, dynamic load can be random, harmonic or impulsive. Random load can be wind pressure, earthquake, which is unexpected but still need to be considered by the design engineers. Harmonic load is equipment vibration due to pulsation or acoustic load. And impulsive load can be relief valve. It is stopping the pressure, so pressure increased and that is loading the system. Fluid hammering, because of the extensive pressure in the fluid, so there will be hammering from the fluid. And slug flow. So these are all the loads need to be considered by design engineers during designing a piping system or component. Requirement of support in the piping system. Why we need to install a support and what are the kinds of supports available. I have put here some photos and some isometric views how the support is being represented in the drawing. To carry out the weight of the pipe fittings valves with or without insulation with operating or test fluid, supports are required. Supports provide adequate stiffness to the pipings against external loads such as wind load, ice, snow and seismic load, etc. To avoid overstressing of the piping material, to avoid sagging of pipe which creates draining problem, to control the thermal expansion or contraction in desired manner, to withstand and dampen vibration produced by the connected equipment such as pump, compressor, etc. Types of supports. There are hanger supports to sustain the dead weight of the piping system. I have seen in our sample project there are some hanger support. So it can be of few types: rigid hanger, spring hanger, which is variable or constant, shoes, and trunnions. Restraint support to restrict the movement due to the thermal or dynamic loading, which can be anchor, which can be a pipe guide, directional anchor, U-clamps, or struts. And vibration absorbers to restrict the movement due to vibration caused by wind, earthquake, or fluid flow. It can be of few types like snubbers, sway brace, and hold down. So guys, you have an idea of a piping system, and we need to now select the materials. Materials for construction are selected and corrosion allowances are determined on the basis of anticipated corrosion or piping degradation under the most severe combination of process variables like steam composition, velocity, temperature, and pressure, resulting in sustained maximum normal operating conditions. Approximate temperature and pressure margins should be added to the sustained maximum normal operating conditions to determine the design conditions upon which the high temperature mechanical design is based. Material selection diagram legend. So there are some legends we are using, like abbreviations we are using in English. So you can see, just for an example, stop this slide and stop the video here. You can go here. Let's say CS means we understand generally carbon steel, and when it comes to plate we use A285, A516. These are all very popular materials. A266 is for forging, tubing A179, pipe A53 grade B, A106 grade B, and API 5L is the most popular standard for the pipeline materials, you know. LTCS is low temperature carbon steel. So these abbreviations, all design engineers, all the piping engineers who is working many years in the plant and refineries, they know very well. This is a continuation of that table. Here are some austenitic stainless steel, duplex stainless steel, super stainless steel, and nickel alloys, how it is being represented. Service temperature during material selection is one of the vital input. So you can see carbon steel with 1 1/4% chromium and half molybdenum. Service temperature range, it can handle -50 to 1200 degree centigrade. But after 850 degree centigrade, it has a creep embrittlement. So you have to take care while designing. Let us take another example like 9 chromium and 1 molybdenum. It can handle -50 to 1200 degree. So this way there are many critical details. I am only discussing here about the basics, so I will not go in more details here. So that was a nice overview of piping engineering, what the piping engineers is doing at site as well as from their table. Whenever we are getting any mistake in a drawing, we are telling that the engineers are doing nothing. But don't forget that they have to consider many aspects and many perspectives when designing a piping system. So they might miss few things. We should be generous for them. So if you like the way of my explanation and teaching, please don't forget to share and subscribe my channel. And don't forget to hit the like button. Signing off for today, Showman.